Okay, what I want to look at here is energy in an inductor, capacitor, resonant circuit. This is, well, not just the energy, but I've already drawn this up because it gets a little bit tricky, as you can see. But basically what we've got is a circuit that's got an inductor in it and a capacitor. And so I'll just talk about various things, and I just want you to be aware of a few little issues that we've got here. So what I've got here, the green is the current, sorry. The red is the capacitor. The black is the inductor voltage. So let's have a look and see what's happening at various stages. When the current is 0, that's when we've got our maximum voltage on our inductor and our maximum voltage on our capacitor. That's when the current is 0. So the phase difference is between those two is 90 degrees, as you remember from your phasor diagram. Now, when the current is 0, if we go to our equation for energy in an inductor, so if I lift that up just a little bit, you'll be able to see. Remember that equation for energy in an inductor, half Li squared? That means that when the current is 0, the voltage on the inductor is maximum, but the energy there is 0. So the energy in the inductor is 0 at that point. But if we look at the formula for the capacitor, energy equals half CV squared, then if the capacitor voltage is maximum, then the energy in the capacitor must be maximum. So this is why I say that this circuit is a little bit like a mass bouncing on a spring. You've got all the energy in the inductor at this stage, in the capacitor at this stage, and none in the inductor. All right. As the whole thing bounces down to here, we've got 0 voltage on the capacitor, 0 energy. We've got 0 voltage on the inductor, but at this stage, this is where our current is maximum. So if our current's maximum, half Li squared is going to be maximum. So this is the point where our energy is maximum for the inductor. Maximum capacitor, maximum inductor. Maximum capacitor, maximum inductor. Alright? So it's bouncing backwards and forwards, like between gravitational potential and elastic, like a mass bouncing on a spring. Now there's a few other issues that we can look at here. A few things to think about as we look at it. Capacitor's maximum negative, so it starts to discharge. Right? But when it was maximum negative, the current was 0. Why was it 0? Because it had got completely charged. There's going to be no current when it's completely charged. Current stops when it's completely charged. So as it starts to discharge, we start to get a current starting to flow. Right? But the interesting thing is, by the time it's got to 0 in its voltage on the capacitor, that's when the current is maximum. So the actual voltage between the capacitor, the voltage on the capacitor is 0, that's when the current is maximum. What that means is, as the capacitor goes from negative maximum to positive maximum, it's the in-between stage when the voltage on the capacitor is 0 that we get maximum current, which is right there. So that's what's happening there. Now it's the di dt that we need to look at to talk about the inductor. Now the di dt is maximum when the current is actually 0, when it's going through that 0 stage. When the current reaches its maximum, di dt is 0. It's like a state. The gradient is 0 on there. So as it goes up to its maximum and then starts to drop down, there's an in-between point where the gradient is 0, di dt is 0. So it's at that point when the current is maximum, or halfway through the discharging and charging stage of the capacitor, that the voltage on the inductor will be 0. Alright, so let's have a look at that di dt over here a little bit. The capacitor is charging back up to Vc max. At that point, the current is coming to 0, and the reason it's coming to 0 is because, as we said, when the capacitor is fully charged, you can't have current flowing through it anymore, so it's coming to 0. But at that stage, it's coming to a fairly sudden stop, so di dt is at its maximum, so that's why the voltage on the inductor is at its maximum. But it goes from a di dt, or the current drops from a positive value and then starts to be a negative value. What does that mean? That means it changed direction. So it changed direction, but the IDT didn't change. It stayed negative this whole way. Okay, so the actual change went from a sudden stop of the current to a starting of the current in the opposite direction. So the capacitor charged up, then it discharged. That's why we went from a positive current to a negative current. Okay, but the IDT, as it suddenly got charged up, the IDT is high, and as it suddenly starts to flow again, the IDT is high. So the maximum rate of change of the current is around that 0 point, when the capacitor has got fully charged and is now starting to discharge. That's the maximum point. Alright. Now, as soon as it starts to flow, alright, as soon as it starts to flow, that's when the IDT is at its maximum. That's when VL max is at its maximum. But as the current builds up, blah, 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 up to its fully negative point, it's going to go through that 0 point, the IDT changing all the time, and that's where your VL max is decreasing. So these are the little things I wanted you to understand. You might have to listen to the video a couple of times to get those points, but I think that pretty much covers a description of the changes that are taking place in this circuit when we've got a capacitor and an inductor.